mentioning some basic concepts of JMP, and then we will also have some hands-on. So I got some data sets, and we can also look at some basic tools and analyses, graphing possibilities all together. So that's the plan for today. Plus, I will also provide some links and resources. So most of the resources are open and online, so that you can also find more information later and that you can dive deeper. And if you want to do something else using our software, it's quite easy to get started and to use our free resources. Okay. So if there's no change request or anything else, let's go. JMP comes as a software for Windows and Mac computers. It's a desktop application, basically. Yeah, so our mothership, so we are part of SAS Institute. Yeah, and SAS software typically runs on servers and even for high performance computing. JMP has been built for the engineer, the scientist, typically the more applied statistician, a practitioner who is really interested in solving real-world problems, learning from data, and have all the powerful statistical methods at hand without worrying about the details, the formulas, or even the technical implementation. So, as I said, JMP is built for real-world problem solving, and that's also a reason why it's used widely in industries. In many industries globally, and so in chemistry, in consumer products, in semiconductor, pharmaceutical. So many industries use JMP, and many of them more or less as a standard tool set, a standard package for statistical analyses. And what's unique in JMP is the ease of use and the interactivity. So that means that JMP makes powerful statistical methods really accessible for the practitioner. The practitioner who has some problems he or she wants to solve and questions to answer based on data. And JMP makes this really easy without the need for coding. So JMP is a no-code package. That means that typically the barrier between the user and the data is really low. So you don't need to program. And that makes the interaction with the data really fluent and intuitive, and really efficient. On the other hand, we won't go into the details here, but on the other hand, just to let you know, you can program in JMP. There's a full development environment, a scripting language built into JMP. It's called JSL, JMP Scripting Language. And this can be used to customize analytical workflows or to automate workflows, to develop any custom methodology or techniques you want to use. So there's a scripting language. There's also an integration with Python and R and Excel and SAS and many other packages. You can also export scoring code from your models built in JMP in any language, in C, language, in Python language, many other languages are supported. So there's some code around, but it's not needed, and we won't use it today. So we will just use the easy point and click and drag and drop interface. And this ease of use has also a benefit in teaching. So it means that you don't need to worry about any closing bracket or a compilation or any technical issues. Yeah, so students don't need to know Python or R or both, or it's not needed. It's more intuitive, and the focus can be on statistical thinking. So think about your data, be data-driven, problem-driven, and then look for some answers. And yeah, this is also nice to engage students and really focus on the methodology and the application of powerful statistical methods rather than their implementation. Okay, so I also have a browser open here, so to point you to some web pages you can explore for yourself later. So if you go to jump.com, yeah, you get to our homepage, and there's also an overview about capabilities. Yeah, so here you see a menu about JMP capabilities, and we also have an overview, the whole workflow, which we call the analytic workflow. So on the left menu, there's also a link to the analytic workflow, and this looks like this. And here you see how to walk from your data on the left to some insights and better decisions on the right based on your data. And what you do is you get your data into JMP, you explore your data, maybe you have to clean it up, and then you start with some analyses and maybe even more powerful analyses, machine learning, some more specialized analytics, and then you share your results. And there are also different options for this. So the important message here is that JMP supports the whole workflow. It's not just for data visualization. It's not just for statistics, hypothesis testing. It's not only for designing experiments and to collect the right data for your problem. It's all built in. So it's a very broad and powerful tool set. And you can click on any of these applications and then look at some use cases. And these are the here. So for instance, we have basic analysis and modeling. Here you see how to fit distributions, testing, and some other methods. And from here, you can also click on the title, and then you will be linked to the JMP online help, which explains you how to do this in detail. Yeah, so the level here is really the workflow, and then you have all the capabilities down here, and then you can look into them and see how to use them in the JMP help. Is there any question? If not, let me proceed here. What else to mention? So if we look at basic analyses and also data exploration, you see that everything is available in our standard package, which is JMP. And if you got the JMP student license, the free license, you have the standard JMP package installed. I assume you have version 17. I'm running JMP Pro 18 on my computer. So what is the difference, JMP Pro, especially in predictive modeling, machine learning, as you can see here? So you get some more powerful methods if you have the Pro package. Yeah, but I think it won't be needed today. And you can create all the graphs and everything, and also some models using multiple linear regression, as you already saw, I guess, using the standard JMP package. Just to make you aware, some more powerful, especially predictive modeling features are in JMP Pro only. And the last thing here is I mentioned that JMP is used widely in industries. And if you want to see some examples where JMP is used, if you want to see some companies, country examples, read about their. Sorry?
It is requested to all the participants, please switch off your mic because it is creating an interruption. Please.
Yeah, thank you. I also invite you to ask a question and to interrupt me at any time if you have a question. But if there's noise, I'm not sure. Is there a question or not?
During
Should
your
I
session,
stop or not?
kindly switch off the mic. After I will give him the time to time session for Q&A. That is the better option because some people don't know their mic is on and off.
Okay. Yeah. Thank you very much. Yeah. So on the left menu, why JMP our customers? Here you can read about customer stories. Yeah, and you can see the problems they have and how they solve them using our software. The relevant message here for students is JMP skills and the way of statistical thinking you use in JMP. So these are really relevant skills, relevant skills in industry today. And many companies look for these skills, for data modeling, for quality control, for designing experiments. So the skills are really, really relevant, and that should be also a good news for students who get started with JMP, because it can make a difference on your CV later on. Okay, there are also some resources here I will come back to later. So I think now let's have a short look at our software, and let me show you just an example first and explain some basic.
Please, Volker, mute all the participants. It is requested you to mute all the participants. There are so many distractions from the other participants. What you say? Because some of on their mic and they are not talking to us. Yes, 3 other more have opened the mic.
Participants. I had the option here, but it's not. There was a Zoom update. The option is not where I expected it to see.
Okay, I will send a message.
Sorry, I don't see this
No,
right now.
I think we don't have a time to waste. You may carry on because our participants are there. When you click on the participants, at the end of the set, they written the mute all the participants.
I did
That
this.
option is for the host.
Here. Now I got it. Yeah.
Thank you.
Thank you. Thank you. Okay. Okay. So everyone is muted now, but you can unmute yourself. So in case of a question, please actively unmute yourself and ask a question, but I will also stop later for questions. Okay, so a first data set. So here we have a data set in JMP. And looking at my journals, I shared the journal with you, and you see these buttons here. Some of these buttons just open a sample data set from SAM data which were installed by our software. And if we look into this button, what's happening there, it's a line of JMP script, and this just opens the sample data set nicardipine.jmp. This one here, the ones with the star, they have the data embedded in the journal. So here it's a bit different. If we look into this, so here we have a new table, and then this data table definition we have here behind that button is opened. Yeah, and if I click the button, we get this data table, which is embedded in the JMP journal. Just to make clear what's happening and where the data are coming from. Otherwise, if you want to explore other data sets than we have on the journal, so on the help menu, you will find the command sample index. And there you can look for sample data sets. This is new in version 18 that we get a search, and now I can look for data sets, and then if I click it, I get a preview, and then I can open it. In version 17, what you probably have, you get an overview about the sample data, or you just open the sample data folder, and there you get access to maybe 500 data sets for different purposes. And many of them are also referred by the JMP documentation. Okay, so this is one sample data set extended with some stored analyses we have here on the left-hand side. So these are saved scripts from some analyses which have been done before and then saved as a script to the data table. I can show you later how to do this, because this is quite useful to save results or analyses within JMP. And I can show you later how to do this. And then I can just click the green triangle and run the analysis again. For instance, this one looking at a distribution. But I want to show you how to start an analysis from scratch, and not just by running a stored script. So that's easy. But we want to see how to do this. What do we have here? We have a data set with 18 columns, and we see it here, 18 columns. And all the columns in JMP typically have variables. So this is the brand of a candy bar. So these are some sweets, some products, candy bars, with different product names and then different properties. And everything is saved. Every information is saved in a column. And each column is a variable. And what's important, so I can also open this preview here. What's important is the type of the data. How are the data visualized and shown in the data table in our cells, and how are the data scaled? And this can be seen in the column properties or the column information, and we can just double click a header, and then we see that there is a column name. So it's name of the product in this case. And then we have the data type. This tells JMP how to show the data. So here, these are strings, characters. And the modeling type, that's the scaling of the data. The modeling type is nominal. So we only have categories or labels, and there's no order. This one here, the calories. So if we look at this column, we see numbers in the cells. We see a histogram here as the preview. And if we open the column information, we see these data are numeric. They are on a continuous scale. So on that column, we can also use the data to calculate a mean and or a sum. So we have numeric data on a continuous scale. And there are many more properties, just to let you know. So to order the values for specific ordering, to add some units or specification limits, to have formulas or some notes where the column is, where the information is coming from, and so on. So this is the metadata, which is also stored on each column. And the rows are the observations. Here it's one product. And in this data set, we have 75 rows, 75 candy bars, different products. So a small data table. Is there any question about the structure of the data, the table layout, the rows, the variables in columns? Here we have some stored scripts, and that's the data table here.
Dear Professor, I just wanted to know how to split the data and concatenate the data, because we don't have a skill on it, because sometimes we have to concatenate, join data. So I would like you to please disjoin, subset data. This should be teach us how to perform this type of things in the JMP.
So I understood how to split data, right? Or how to arrange the data, how to prepare the data for an analysis.
Yes.
So this data set, it's a sample data set which is already prepared, for an analysis. So nothing to worry about. But in real life, you are right. In real life, it's typically different. So you may have to arrange the data so to get this structure, and maybe you also have to clean it up. Yeah, and
No, I'm interrupted you. I'm saying how to split data, sample size, sample data, because in table there are many options.
mhm.
You can see the table option, you can see that the other option. So I want to know how to use this, because I don't know how to use this. I try my best, but I cannot get the sample data or join data. I'm just want to know how to use that icons.
How to use the icons
That
or
icons, which is subset and concatenate and
this?
join.
Yeah,
That is the
okay.
options are given in the table.
Yeah, yeah, yeah. So the arranging the data is typically done using the table tools. Yeah, and the table tools allow you to prepare the data and rearrange it and sort it and also combine data from multiple tables and concatenate them, or if you have different tables with different information, so you may also add them and you have some variables from table A, other variables from table B. And all of these operations are typically done using the table tools, yeah, on the tables menu. And I can show you one other overview about the menu so that you can get some ideas at least for these table tools. That's the jump starter. Depending on Windows or Mac, you find the jump starter on the window menu on a Mac, and on Windows on a PC, it's on the view menu. So if you open the jump starter, you have here the options for data import. And here are the table operations, and there you see what what you can do. So a summary and then subset. What is subset about? It creates a new data table with a subset from your original table. Yeah, and also sorting, stacking, splitting the data table, concatenating. So here you see what these tools do. So if we want to get a subset, maybe all the Hershey products, yeah, with the brand Hershey. Yeah, so I could choose table subset, and now I specify the subset. So now I can choose, for instance, the selected rows. And this is probably the easiest way to go. If you don't want to just get a random sample, but no, we don't want to get a random sample or stratify our data. So we want to get a subset. If we want to get a subset by brand, we could now old rows, brand. Filtered rows. That's the way to go. Filtering. So we want the brand Hershey only. So I choose Hershey, and now we see a preview. So we have 29 rows with the brand Hershey. And now I can click OK, and then we get in this case, a new table, with that subset. So, okay, this is the subset with 29 rows only. But all the information is in here. So we have again 18 18 columns. Let me close this again. So this is just one example to use a tables tool. You don't have to start the tools in many cases. So there are also easier ways. So here's a red triangle. One takeaway today is red triangles are your best friends in JMP. They are context menus. So this one is about the rows. Yeah, so here we find commands to work with our rows in our data table. So this is about the columns, and this is about the rows. So if I open that menu, I see row selection. So I can also start from here. Yeah, and I can select the rows where, and then I get a similar filter. Yeah, I can select the rows where the brand equals Hershey's. That's the correct one, right? Hershey's. Hershey. Yeah. Yeah, and then I click OK, and now all the rows are selected. Yeah, and here we see selected. That's the row status. Yeah, and we see all the selected rows. And on this selected status information, I can also do a right click. Yeah, and then choose data view. And then all the selected data is then populated into this data table here, which is the same result now, but not starting the full table tool from the menu, which gives you the highest flexibility with random selections and all these features. But this is an easier way to do this. So selecting the data, let me close that one. And I click here. That's maybe a bit of a hidden feature, a tip. So to unselect, if I have maybe these rows selected and also some columns selected, to unselect, I can click here to unselect the rows. I can click here in this gray triangle to unselect the columns, or I click escape to unselect everything. So that's maybe a helpful shortcut. Yeah, but I can also take this cell and right click and then also select all the matching cells. So now all the cells which have the same value are selected, and if we take the full information, all the columns, again, we have the 29 rows selected. Yeah, so there are many ways to get to a subset, and easier. Most of them are easier than opening the full-fledged table tool. Another one is if we look at some distributions, so we look at the brand information and maybe the calories. Yeah, we see this here. That's a distribution output. Let me unselect a distribution output created from this data table. Let me move this to here. And now we have an overview about the different brands in our data table. Remember, brand is nominal. So that's this little red icon here, nominal data. So we get a bar chart with counts, how many Hershey, and that's the the most prominent, most popular brand. And then we have the calories. And now I can also click on a brand. I can select Mars or Nestle or Hershey. And you see everything is connected. So clicking on Hershey selects all the Hershey products. We also see the calories for the Hershey products. So I can also point there and see some more information. Maybe more interesting is to choose all the products with high calories, and then we see that, oh, many Hershey products have high calories. But back to our task, get the Hershey products separated. So I can also select it here, and then get the data view, or even right click. Sorry. Not right click, double click. I wanted to say double click. So I can also double click here, and then you get the subset. And the last thing, so I hope not to confuse you, but to keep you in the flow, there are many ways depending on where you are and what the current view is. You get many ways to do the same thing. So here, selecting data. So what's really helpful is, and also recommended, is a data filter. So on the rows menu, I can filter the data, and this is a global data filter which works on all the windows we have open. And here I can choose, okay, let's add the brand. And now we have all the brands here on a filter. And we can use this to filter just the Hershey or these ones or Charms, or I can also do a multi-select. And then I can also clear the filter, and then everything is unselected again. I can also combine this. There's no limitation here. Calories. Calories is continuous. So adding this filter. So now I can say Hershey products, and I choose the high calorie products. Or I can move it here, the low calories products. So back to high calories from Hershey. And by looking at our data table, we see that these are these 6 rows, which are now selected. And here I can again get them into a subset. So these are the products from Hershey with high calories in that range I have selected on the filter. And if you want to monitor them, and if this is a special subset, you can also keep it on the original data table, but maybe set a special marker here. So we can color or mark this by, sorry, not by these. So here is a special marker, so we can select this guy. So now we have the stars. Yeah, and when we visualize the data, yeah, we can easily see where these 6 are. So if we look at calories on the graph builder, calories, this is just one dimension, calories, and these are the 6. And you see they have different markers compared to all the other data points. And by total fat, if we add total fat here, so this is the graph builder, we still see that we have these ones selected here. So I also don't need a data filter. Maybe I just do a multi-select somewhere. Yeah, and then you select the subset, and then you can do the subset function and get it into a separate data table, or you give it a special marker or color just to mark it, to signal this is the subset we are interested in, we want to monitor. So different ways to use it. If you think we are more interested in all the other data and we don't want to look at these high calories Hershey products because they are so special, we want to exclude them from our next analysis, then you can also choose the red triangle and then you choose hide and exclude. Yeah, exclude, that's this symbol here. Yeah, it's like no parking. And this means these data won't be used in any analysis, calculating the mean or building a model. They won't be used. They are excluded. Yeah, and if you also choose hide the selected rows, so this is the hide function. So now there's also a mask symbol, and that means we also won't see them in any graph, any visualization anymore. So if you look at this here, so the star data points, the 6 data points are gone. They are not shown anymore. They are hidden. And this hidden, excluded status is also shown down here. So you can always monitor how many rows are currently selected, how many are excluded, and how many are hidden. Yeah, and if I want to undo this hide and exclude, I would have to select them here first, or I right-click exclude it and then clear this information, this status information. I also don't want to hide anything, so I right-click and clear this information here. Yeah, take away red triangles and right clicks always provide typically the information you need in a specific context. We could spend easily half a day just looking at these tools here. Concatenating, that's concatenating vertically. So rows, some rows from table A, some rows from table B. Joining means horizontally, so some columns from table A, some columns from table B. And if you have data distributed over many data tables, yeah, you can also use an open multiple, and this can also join data from multiple tables, maybe 100 tables in a subfolder, and you can open them all at once. So that's open multiple, and then you don't need to do any manual concatenation. later on. Okay, let me proceed and look at the red triangle again. So what if we are interested in a distribution? So here, the distribution of calories. I look at the distribution platform. So here, analyze distribution, the first one. Yeah, I choose the variable. So this is a common launch of a JMP analysis. So you see all your variables, you assign them into roles, yeah, and then you click OK. Yeah, and then you get a first output. It's not the starting point, it's not an end result, because this has red triangles and right-click menus to dive deeper and add some more information, run a specific test, and use that output to move on. Yeah, so here on the red triangle, let me maybe turn the histogram around. It changed the color, so let me get the color back. So now we see the standard output, a histogram, a box plot. Now we see the quantiles and summary statistics. There are gray triangles to collapse or expand sections, but I can also remove them here from display options. I don't need the quantile information. I switch it off. Yeah, summary statistics, I can close them. I could also switch them off, or there's a red triangle. I can also add more summary statistics, like variance, skewness, so some others you can select there, and now they are added. Yeah, and here on that red triangle, we can check for normality, for instance. So to add a normal quantile plot, just switch it on. You see the data points are expanding or crossing this dotted zone. So there's some evidence that the data are not from a normally distributed population. And I can switch it off again. On the same red triangle, I can test for mean, for instance. That would be a t-test, as you see here, if you don't specify the standard deviation. Or I can fit a known distribution to our data. Yeah, any of these distributions, or I ask JMP, fit all of them and show me what's the best one. Yeah, here we see a normal 2 mixture, that's the best fit. If we are interested again in a normal distribution, I can also switch it off, activate normal, and now we see the normal distribution fitted to our data. And we see some detailed results down here for the fitted normal. And there's a red triangle. So here I can ask for goodness of fit, for instance, and then JMP runs a goodness of fit test. And JMP also knows which statistical test to use. So here we have 2 tests, Shapiro-Wilk and Anderson-Darling tests. And these numbers in orange, they are p-values. Yeah? And on many numbers, you can just hover with your cursor and you get a tooltip telling you this is a standard error, the estimate of the standard deviation of the estimate. If I hover here, this is a p-value. Yeah, and it's pretty small, so it indicates significance. And significance is also shown by color, by this asterisk here. So significance, what does it mean? What is it telling us? So there's also a hint here. So the null hypothesis is the data is from a normal distribution, small p values rejected. So here's evidence to assume that the data are not from a normal distribution. Just to show you red triangles. Yeah, so you dive deeper and step by step, it's really progressive and unfolding the analysis. Yeah, when you start here, a univariate analysis or even a bivariate analysis, you get a first output and then you use the red triangles to dive deeper. Now, for graphing, maybe you want to tune your access settings or you want to explore your data. How can you do this? Yeah, so if you point to the axis, you can move it. If you point to the end of an axis, you can also zoom in, zoom out. You can double click an axis and then you can fine tune the tick marks or set a reference line and change to a log scale. So just by double click, there are also some other hidden features like this grabber tool here. If I use this one and move up and down, I can also change the binning, the bin size. If I move left and right, you see that the bin positions, locations are moved around, and then you can maybe select a representation of our data using a histogram which really supports the story you want to tell. So this is a different tool, a grabber, the hand tool, which can be used for that. The standard tool is the arrow, this one here. And you can change it just by clicking A, and then it's back to arrow. This is the question mark tool. So if you don't know what this is about here, this box plot, and then you see this red bracket, what is it? Maybe you know, okay, we see the quantiles and the whiskers and maybe some potential outliers, but what is this bracket? Take the help tool and drop it here, and then JMP will open the online help, and that's context sensitive. So it enters the help where you can find some information answering what this is about. And this is the shortest half. So it's the region, the shortest region, which covers 50% of our data. And if you want to fine tune the output, you can right click here and change the fill patterns, histogram, and so on. But you can also right click here and I can choose customize. And then I can customize the box plot, and here I can deactivate the shortest half. Or I can show it in green or another color, or I can just switch it off. And now it's gone. Again, red triangles. And if you don't find anything you want to change on a red triangle menu, just try a right click and see what you get there. Any question about this so far? What I would suggest as a next step, maybe if you could open the Titanic passengers data set. Yeah, so this is a quite famous data set also in teaching, data exploration, visualization, some basic modeling. If you could open this data set, and I will show you some more information on another data set, big class. Big class is a bit, maybe a bit boring, but it's easy to see, easy to understand what we have here. We have a small data set with 5 columns, 5 variables, as we see here. And these are kids from a school class. And we have 40 kids, 40 rows, and the information we have about each kid is the name. No, double click. The name, we have the, sorry. There's some latency right now. I don't know where it's coming from, but yeah, let me proceed. So age information, sex information. Unfortunately, the column does not highlight. I select it, but it doesn't answer my clicks. What's happening? Okay, height and weight. Yeah, and you should look at you can also open the big class data set, but I would like to ask you some questions about the Titanic passenger data set. So I assume you know about the Titanic and what happened, and the interesting information here on this data set is the survival of the passengers. And survival is a binary information. So a passenger survived, so then it's yes or not, and then the value is no. So how many passengers are tracked on this data set? Can you see this? Here is passenger number 1. Number 1 means it's the passenger on the first row. Yeah, we have a second, a third, and many more passengers. How many? Yeah, you're muted, but you can unmute yourself if you want to answer, or type it into the chat. This is the answer here. We have 1,309 passengers on this data set. What type of information do we have? Age is numeric data, on a continuous scale. And we have this dot we see here. What is the dot telling us? It's a missing value. So for this passenger here, 16, we don't know the age. So there's no value in that cell. So for continuous data, we see a dot. For categorical data, so nominal or ordinal, we would just see an empty cell. So when it comes to outliers, you can see on the distribution output or in graphs, if you see an outlier, you may want to explore it and then decide, should we keep it? Should we exclude it? Should we correct it? Yeah, and for this, and also for handling missing values like this here. So there are tools built into JMP, and if you look at screening, so that's the very first stage when you screen your data set and try to understand it and also maybe clean it up. Yeah, so you have options to explore outliers. Yeah, and there are also options for multivariate outliers, not just univariate. And you can explore missing values. Yeah, so you can see where you have how many missing values, and you can also fill the gaps and do imputation using these tools. I would suggest you refer to the documentation or look up some videos. So I would prefer to move on with some analyses and graphing for the remaining time. The tools are also quite intuitive and easy to use, but here is where you find it: analyze screening, explore outliers, and missing values. So we have 1,309 passengers. What about survival? How many passengers survived? Can somebody provide that information? Where fit the missing? How can we fit the missing values? How to fit the missing values? I don't exactly get your question, but if you have missing values and if you build a multiple regression model, and if you have this age variable in your model, then the whole row would be skipped. Yeah, and that would mean that we also don't use all the other information we have about that passenger just because one piece of information is missing. Yeah, and that's the reason and a good reason to fill the gaps, even with the best guess. Yeah, even just with an average value. So it will disturb the model a bit because the missing value is probably not the correct one, but we would get all the other information which is correct into the model. Yeah, so after doing some imputation. And then you just fit a model and you fit a model. If you have missing values, you will see that not all the rows will be used. If you do imputation first, using this tool here, missing values, and then impute, then more rows will be used. And maybe you can also compare the models side by side and see if the imputation improved your modeling step. I hope that answered the question here. So how many passengers survived? Different ways to answer this. I don't see a number on the chat yet. So let me show you some options. So we already know distribution. So interested in survival and okay. So that's a very easy way to do it. We just see yes and no. Here we have the counts. 500 passengers survived. And good news, survival is given for all passengers. We have no missing values here. So we know the survival status for all 1,309 passengers. And I can also click here, and then you see 500 passengers are selected. These are the survivors. We can just select here. So that's one way to do this. You can also create summary tables using the tabulate platform, analyze, tabulate. And here I could put the survival in here, and then we see a statistic. By default, we see the numbers, the counts, and again, this tells us 500 survived. And if we want to break it down by different port, I can also add the port. The port is a 3-level categorical variable, and this is Southampton in the UK. So 304 passengers from Southampton survived. And when you are done with such a graph, I can also add the some other information here. Maybe so we can really break it down by survivors and then sex and then the port. I can also replace port by passenger class. So now we are looking at female, male, and one first, second, third passenger class, and we see all the counts. If this is what you want, you can click done. And then this could be the output. By the way, you can edit all titles you see, and to adapt it to your data. Okay, so that's the number, the survivors. What about survival and passenger class and sex? Are there any relationships? So how could we start exploring this? Again, distribution. So I can put several variables into the same output. So these are all bar charts because categorical data. And now I click survivors. And now we see that there was a better chance to survive if you were in the first class than in third class. There was also a better chance to survive as a female than a male. And if you want to get the numbers and details, you can just use your mouse cursor and then you see the total number and then the survived number. So this is just by clicking and exploring. If you want to use a more statistical approach, you would look into maybe, or you would start with bivariate analyses. So if you're interested in survival by passenger class, I click OK. So we have two variables, one Y, one X, and this is the output, the report. So now we get the mosaic plot as the visualization. We get a contingency table and then chi-square testing. And the test is significant. So there is an effect of the passenger class as we saw on survival. And again, you can select the non-survivors from the third class, the biggest group, just by clicking. And the red triangle gives you the opportunity to dive deeper, run more tests, and get more information from this scenario, this analysis. The same again, so fit Y by X. So I'm still interested in survival. That's my response. But we look at age. Was there a better chance to survive based on the age of the passenger? What is this? So remember, it's the same platform. The platform fit Y by X, which is a bivariate analysis, 1Y, 1X. But here, JMP automatically does a logistic regression, because survival is categorical, age is continuous, and then we see that with a higher age, so the probability to survive decreases. Plus the statistics down here. I'm not sure if you can follow on your computer using the same data. Feel free to provide some feedback. If you want to move ahead, if you want to look into another analysis, or if you are stuck, if you have questions about it, just let me know. So looking at the analysis tools, maybe you are a bit overwhelmed by all the options here, but the high level structure is univariate statistics, distribution, bivariate analyses, fit Y by X, and then you have the multivariate tools down here. Modeling, the screening options. And if we want to build an exploratory model, a classification tree in this case, it would be one decision tree. And our response we are still interested in is survival, right? So what can be used to explain or predict? It's not really a prediction because this is a unique event, fortunately. But we can try to explain the survival by some independent variables or factors like passenger class, sex, age, number of siblings, spouses, and parents and children. Yeah, let's just take these into a tree. So I add them as factors, and then I choose OK. And now we see we have all data points in one group. This one here, all 1,309. And the red ones, let me check the colors. The red ones did not survive, and the blue ones did survive. And now I can split the data. That's the partitioning of the data, splitting the data by a single factor. And we try to maximize the difference between these two groups, so that we get as many survivors into this group and as many non-survivors into this group as possible, to make these groups really different. And the best factor to do this is the sex. So female here, male here, and then we see that female is really blue and male is really red. I can do another split, and move on. And then you see that also some other information will be used to split the data. Even do some more. So that means if the passenger was female, and in the first passenger class, so we can also add some more information. In the first passenger class, there was a 96% probability to survive. On the other side, a male passenger with an age below 10 or unknown, and more than three or more siblings and spouses, then there was an 8% probability to survive. 96 versus 8%. That's just an example for a decision tree. The tree can also, which is a model, the tree can also be used to get an overview about the factors which were used to explain survival. And we see what was most important and the second one, and the information about parents and children was not used at all so far. So it did not help to split the data into blue and red, or survived and not survived. And you already asked about fitting a model. So fitting a model to explain or predict survival. Fit model, that's a family of linear models. And depending on our response, so which is still survival in this case, JMP chooses a default modeling method. In this case, it's a nominal logistic regression. And you see there are also many other ways to build models using this fit model platform. So this is our response, the why. Let me choose some information again. So I take the same 5 factors and I choose factorial to degree. So this is a macro which adds the main effects. So the 5 factors and also the combinations. So these are combinations, 2-factor combinations, so to model some interactions. And now let me run this. That means let us fit the model. And we have the summary. In this case, passenger class was the most helpful, most significant factor, a main effect. Here's the p-value, smallest p-value, and then there was sex, and then the interaction between passenger class and sex. The whole model test, the whole model is significant, so it's much better than just guessing. We have some fit details. So a misclassification rate, that means if we use this model to predict survival, we would be wrong in 18% of all cases. So I can, parameter estimates, the estimated parameters. We close this and this. And starting from the bottom, we see that this interaction is not significant at all. So I can remove it. So bottom up, this one is not significant. I can remove it. This one is a main effect. It's one of our variables, parents and children. What we saw earlier on the tree, which was not used. Here, it's not significant, the main effect. But this hat symbol tells us that the factor is used on a higher order term. And that's this one and this one. And this one is significant. So it would be a good idea to keep this as well if it's used on higher order terms too. So let us keep this one and this one. This one can be removed. And this one can be removed. So now let's keep the model like this. And then what's great for explaining the model, understanding the model, is the profiler. So the profiler shows you the traces. So here we have our response, and the response is survival, and we see the 2 probabilities. It's a nominal logistic regression. We are estimating or predicting the probabilities to survive or not survive. And then we have the traces for each factor in our model. And we see that the probability to survive, this one here, goes down if we move from the first class to second class. And it really drops if we move to third class. And if we are not female but male, it drops further. And changing male and female shows us that it not just moves this passenger class curve up and down, it also changes the pattern. So for female, the worst class is the third. But for male passengers, the worst class with the lowest survival is the second. It's a slight difference, but you see the interaction just by setting the the factors. Yeah, we also see for continuous factor, if the passenger would be younger, the probability to survive increases. And for older passengers, the probability decreases. Yeah, so you can really set a passenger profile and then get the predicted survival probability. So that's the prediction profiler, which is really helpful to understand a model. And as I said, from every model you can, on the top red triangle, you can save the formula. Yeah, so here from this model, we can save the probability formula to our data set. Yeah, and now, oh, I already did it twice. So these are the same. Let me delete them. So we get this. Yeah, so that's the decision, survived or not survived, based on the predicted probabilities. And here you see the formula, but the probabilities are the formulas here. So the probability to survive, so for yes, is this one here. So you have the logit functions, so what you typically see in logistic regression. And now we could also use the graph builder and take the real survival we know, and then this against the survival based on our model. Yeah, and now this is correct and this is correct. But this group is, these passengers survived, but were predicted as not survived, and vice versa, another error. And these two together, these are the 193, which would the model not predict correctly. So these are the misclassifications from our model. Okay. So that's the fit model. And the graph builder is really recommended as an exploration and the main visualization tool. Now, as you saw, you get many visual outputs also from analyses, but this is the drag and drop visualization tool. So we can look at survival by age, for instance. Yeah, so now we see the dots. We can change it to box plots. If I press the left mouse button, I can also add another graph element, the data points again. So now the data points, and the box plots are overlaid and combined. If I worry who's this one here, so I can also fix this information and tag it, and have a tagline here if this is interesting. If I want to break it down by sex, I can drop it here or here, wrap or overlay. So now we see sex by color, or this way. But I can also do some grouping. So now we have the female passengers in the upper half and the male passengers in the lower part, and we can combine the distributions of the data in all 4 groups. You don't need to stop. So you can also do this for each passenger class, and break it down further. Or passenger class, maybe this is an additional information, have the passenger class by color. So when you're done with the graph, you click done. Maybe we don't need all the legend information a bit. So we need the colors. But I can maybe remove the H. We don't need this, and we don't need this. So now we see the passenger class, the additional information, and you can right click and do a lot more and change colors, fonts. Also double click here to change access settings. This is you can have any name here. And with any graph in JMP, to get it into a PowerPoint slide or on a paper, maybe you would use for your poster. So there are 2 steps you should know about. One step is that you select what you want to take over, what you want to copy. So you sometimes, this is nested and structured, but this is just one graph. So I select everything, and the selection is done by using the selection tool. So this is the first step you should know about. So the cursor changes into this fat plus sign, and now I can select the graph. By clicking the title, the full graph would be selected. I copy this, just copy, Control C, that's easy. And then move over to Word or PowerPoint. And the second trick is to not just paste, but use a paste special. And if you are on Windows, it's an enhanced meta file. If you are on a Mac, choose PDF and then click OK. And then you get a vector graph which can be resized as you want without losing any quality. So this is the one way to export outputs. Another way is just export, on the file menu, export this as an image or HTML5 with some interactivity. An image, you can also choose a vector graph formats or PDF to export the graph. What I want to highlight is a resource we call the Learning Library. And the Learning Library can be found at jump.com/learn. And you get to a web page, what you see here, and it's called the Jump Learning Library. And there you have how-to guides. So while our documentation has thousands of pages and all the details and technical information and references, these are getting started guides. And for instance, if you are wondering, how can I build a decision tree in JMP? So here under data mining, modeling, you see classification, regression tree. Choose one of them, and then you can look at the guide or watch a very short video. And all the guides are single pages. So on a single page, you see, what is this, a classification tree? What is it? How to build it in JMP, using some sample data, get you started building a decision tree. That's what we saw earlier. And then also how to interpret the results. Plus some further reading, where to find more information, typically a chapter in the documentation. So the Learning Library, and what I would suggest is that you download all the guides. So then you get a single PDF document with all the guides. And this looks like this. So this is for version 17, the JMP one-page guides in a single PDF. You see an overview, all the topics. And as you see here, there are also guides for creating publication quality graphics, both for Mac and for Windows. How to save JMP results. So also the basic steps are explained here, plus the statistical methods, correlation, regression, time series, multivariate, data modeling. So for 100 standard methods, you get a getting started guide in JMP, and this bundle, the PDF with all guides, also has some bonus additional information we call the analysis guide. And here you also see if you are analyzing one variable, what are the typical questions you ask? What are the statistical techniques you typically use to address these questions? And what are the guides which help you with these methods? Next one is a single factor and a single response. So a bivariate analysis, questions, techniques, and the guides and platforms in JMP. So this can be really useful to guide you how to analyze a data set. And that's also part of the Learning Library bundle. So quite useful for students. And what I mentioned at the beginning, what I wanted to show you is how to save something in JMP. So if I want to save this result here, this graph builder output, it's in all platforms on the top red triangle, this is the top level red triangle. Open it and then go down, and there you can save this as a script, for instance, to the data table. And if I do this, call this my graph, you can have a more explaining, helpful title here, and I click OK. Now I can close it. I could even close the data set, reopen it later, and then we would have it here. So what's inside is again a jump script, starting and configuring graph builder. But I just need to click the green triangle and I get back to the same output again. Be careful, if the data changed in the meantime, the result would change as well, because the analysis is redone again, also on the new data, the current data. So we get back and you get all the functionality, and you can start to modify it or to change it, to clone it, or what you want to do. So it's really quite useful to save some interesting results to your data table, to reproduce it later. Okay, can we get this book? It's hard for me to read the chat because the text is so small, but I could read this. So the book, I think you mean this book here. Yes, this is available for download, and you can find it in the learning library. In the learning library, if you enter jump.com/learn, and then it's this button here, download all the guides as a single PDF document. And that's the book, the PDF. Download all guides. That's the one. Or take the overview and just pick what you need. But I really suggest to get the full PDF, because then it's searchable and quite easy to use and at hand when needed. The next one is goes in. Yeah. One last thing I want to mention is this online, no, not this one, Statistical Thinking, this online course. So on the journal, you also have some resources here, also learning resources for students. And these resources include an open online course. And the course is called Statistical Thinking for Industrial Problem Solving, STIPS for short. And there are 7 modules. And each module takes a few hours. And maybe this one can be recommended for creating posters and helpful visuals, how to explore your data and how to communicate with data, how to create effective visualizations. So if you want to learn about this, take this module for free, or to learn about hypothesis testing, basic statistics, some predictive modeling. So all of these modules are free. They are quite entertaining, very short videos, very to the point, nice demos, and also some quizzes and exercises. And by using these modules in our learning environment, you also get access to JMP Pro through your browser. Yeah, so that means to work through the exercises in these modules, you don't need a local installation of JMP. You just log in and register and log in to the virtual learning environment. And then on the browser, there's JMP Pro. Yeah, and you can use JMP Pro for free, but it's just for the training data which are used in these modules. So you cannot upload your own data set. It's just for learning purposes in this program. That's the MOOC, Statistical Thinking for Industrial Problem Solving. If there's a question, I would prefer to answer any question. Otherwise, I'm also thinking if I missed anything important here. Just summarizing again, you get your data into JMP by opening. For your information, you can also open an Excel spreadsheet. So if I open this in JMP, let me file. It's an Excel spreadsheet. So now I'm opening an Excel file in JMP. I get a preview. Yeah, I can specify where the column headers are, where the data starts, how many columns. I can also select the worksheets. If the data are spread over several worksheets, I can select them and they would be concatenated if this option here is checked. And if I'm happy with the preview, I would say import, and then the data is imported into a JMP data table. So these data came from an Excel spreadsheet. What I suggest is that you check the modeling types. So source table, okay, that's some information maybe we don't really need. But the brand, the name, is this really nominal? Yeah, it's text information. Yeah, and calories, all the other variables, the columns only have numeric data. So JMP automatically sets continuous as the modeling type. Yeah, so that's the blue icon here. This is a continuous variable. Again, double click, you can see it. You can also change this, change it here. Just double check the best guess JMP did during the import. There's a link on the chat. I'm not sure what this is for, if it's for me or for the participants. And when you have the data ready, maybe using some table tools to rearrange it, you mainly use analyses platforms from the Analyze menu and graphing menus from the Graph menu, but the most versatile graphing tool is the Graph Builder, drag and drop. And Analyze is about univariate, bivariate, and then multivariate methods you can find down here. So if you keep this in mind, I hope that it's easy to navigate the jump menu. Any question? If there's any question, just unmute yourself, please, or put it into the chat. If not, I would stop the recording now. Okay.